Example 3. Can you write down the chemical formulas of the ions that form the following compounds? A. KCl. From the chemical formula, KCl must be an ionic compound because it is made of metal and nonmetal. For the chemical formula of an ionic compound, the cation must be in the front, the anion must be at the end. Next, we need to find the charge of the cation and the charge of the anion. We need to use a periodic table. Potassium is an alkaline metal. Therefore, the charge of the most stable ion of potassium is +1. Chlorine is a halogen. For the most stable ions of the halogens, the charge is always -1. B. CaCO3. It is also an ionic compound because it includes a metal and nonmetals. For the chemical formula of an ionic compound, the cation is in the front, the anion is at the end. At this point, you may wonder, Dr. H, how do you know CO3 is a group? Ca is a group. Well, this requires you to remember a list of the most common polyatomic ions. If you remember that list, you will know CO3 is a polyatomic ion with a charge of -2. Next, we need to find the charge of Ca in CaCO3. There are two methods. The first method is to use a periodic table. Ca is an alkaline earth metal. For the most stable ions of alkaline earth metals, the charge is always +2. The second method is based on the fact that the net charge of a neutral compound is equal to 0, and the net charge is equal to the charge of the cation plus the charge of the anion. Since we do not know the charge of Ca, let's assume the charge is +x. Within the compound, we only have one Ca ion. For the anion, the charge is -2. We only have one CO3, 2-, and the sum is equal to 0. Then we can solve this equation to find x. Let's look at the third example. C, Na2SO4. It is also an ionic compound because it is made of metal and nonmetals. If you remember all the polyatomic ions, you will know this compound has SO4, 2-. You may ask me, Dr. H, is the cation Na with a charge or Na2 with a charge? Let me remind you, metal will not form a polyatomic ion with another metal or with itself. Therefore, the cation must be Na with a charge, not Na2 with a charge. There are two methods to find the charge of Na in the compound of Na2SO4. The first method is to use a periodic table. Sodium is an alkaline metal. Therefore, the charge of the most stable ion of sodium is +1. The second method is the same as we did for calcium. The charge of one sodium ion is +x. Within the compound, we have two sodium ions. The charge of the anion is -2. We only have one anion, and the sum is equal to 0. D, Mg H2PO4 2. Well, it is another ionic compound. In general, when you see a parenthesis in the chemical formula, within the parenthesis, it is a polyatomic ion. As I emphasized several times, you need to remember all the polyatomic ions. To find the charge of magnesium within the compound, we have two different methods. The first method is to use a periodic table. Magnesium is an alkaline earth metal. As we know, for all alkaline earth metals, the ions have +2 charge. The second method is the same as we did for calcium and sodium. E, Al NO3 3. If you remember all the polyatomic ions, you will recognize the anion is NO3-. We have two different methods to find the charge of aluminum. The first method is to use a periodic table. Aluminum is here. As we know, for this group, the most stable ions all have +3 charge. Apparently, you can use the same method as we did for calcium, sodium, and magnesium to calculate the charge of aluminum. But I would rather to omit that. I think I already give you enough examples. FCu parenthesis ClO2, 2. This is also an ionic compound. The cation is in the front. The anion is at the end. As I mentioned earlier, within a parenthesis, generally it is a polyatomic ion. If you remember the most common polyatomic ions, when you read this formula, you may immediately recognize that ClO2 minus is the anion for this compound. Next, we need to find the charge of the cation. From the periodic table, copper is a transition metal. As we have learned in class, we cannot predict the charge of the transition metal ions. Therefore, we have to use the second method to find the charge of the cation. We can assume the charge of the cation is plus X. From the chemical formula, we only have one cation. Therefore, we multiply by 1. The charge of the anion is -1. We have 2 anions in the compound. The sum is 0. We can solve this equation to find X. Can you follow my examples to work out the rest of the problems? These are the answers for these problems.